Hi everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, I will be covering this lesson about medians and centroid of a triangle. What do we mean by these two concepts? Okay, let's start with median of a triangle. This is a line segment drawn from the vertex of a triangle to the midpoint of the opposite side. Okay, let's consider this triangle ABC. This is one vertex of this triangle. And if we are going to draw a line segment to the midpoint of the opposite side is segment BC. The midpoint or the center is this point. So if this is the midpoint, it means the length of segment BD and the length of segment CD are equal. Okay, from this vertex, draw a line segment to the midpoint of the opposite side. It means this line segment is a median. Triangle has three vertices. It means there are three medians. This is another vertex of this triangle. So, draw a line segment to the midpoint of the opposite side. Then this is another median. What about here? This is a vertex. And if we are going to draw a line segment to the midpoint of the opposite side, we have this third median. Okay, now, what does this median imply? A median of a triangle divides the area of the triangle into two equal parts. Okay, let's consider this median. This median divides this triangle into two triangles. And the area of these two triangles are equal. Okay, why equal? Take note, this length and this length are equal. So it means bases of these two triangles are the same or equal. And also, the height of these two triangles are equal. So when two triangles have the same base and height, then the area of those two triangles are equal or the same. That's why the median of a triangle divides the area of the triangle into two equal parts. Okay, moving on. What about the centroid of a triangle? The three medians of a triangle intersect or meet at one point. And this point of intersection is what we call the centroid of the triangle. Okay, considering this triangle ABC, so from this vertex to this midpoint, so this is median. From this vertex to this midpoint, another median. This vertex to this midpoint, we have this third median. Okay, these three medians meet or intersect at this point. So this point of intersection is what we call the centroid of the triangle. And this is represented by capital letter G. Okay, there is this important concept of this centroid of a triangle that you need to remember and understand. And that is, according to this property of the centroid of a triangle, the centroid of a triangle divides each median in the ratio 2:1. That is measured from the vertex. Okay, let me explain this concept. Let's consider this triangle ABC. So from this vertex to this midpoint, median. Vertex to this midpoint, another median. And from this vertex to this midpoint, we have this third median. So this point of intersection is the centroid of this triangle. If you can recall our lesson about the mid-segment of a triangle, okay, let's say this is triangle A, B, C. This segment, midpoint is this point. So if this is the midpoint, then from here to here and from here to here, equal in length. What about this segment AC? Midpoint is this point. So if this is the midpoint, from here to here and from here to here equal in length. If we are going to connect these two midpoints, then this is now our mid segment. And this mid segment is parallel to this segment. Okay, another concept that you have to remember is the length of this mid segment is half the length of this segment. So if this is A, then it means the length of segment BC is 2A. And when we draw this mid-segment, we now have this triangle and this bigger triangle. And these two triangles are similar figures. Okay, why similar figures? We have this common angle. And since these two lines are parallel lines, then these two angles are corresponding angles, equal in measures. This and this angle are also corresponding angles. So this is AA similarity. So these two triangles are similar figures. So if similar figures, then the ratio of the length of the corresponding sides are constant or equal. Okay, take note, this is half the measure of this segment. This segment corresponds to this segment. It means the ratio now is 2 is to 1. Okay, let's consider this concept to understand this figure. So, as I mentioned a while ago, this is the midpoint of this segment. This is the midpoint of this segment. If we are going to connect these two midpoints, then this is now our mid segment. This mid segment is parallel to this segment. And again, this is in the ratio 2 is to 1. So 2 is to 1. Okay, when we draw this mid segment, we have this triangle and this bigger triangle. These two triangles are similar figures. We have these vertical angles equal in measure. Parallel lines, it means this angle and this angle are alternate interior angles, so equal in measure. So this is AA similarity. That's why these two triangles are similar figures. So the ratio of the length of the corresponding sides are equal or constant. This side corresponds to this side in the ratio 2 is to 1. This side corresponds to this side, so it means 2 is to 1. And also, our median here is in the ratio 2 is to 1. So this is 2 is to 1. Okay, what about here? This is our median. Midpoint, midpoint, connect. This is our mid segment. So we now have these two triangles. And these two triangles are also similar figures. Okay, this segment corresponds to this segment. So this is in the ratio 2 is to 1. This segment corresponds to this segment also in the ratio 2 is to 1, including this median. This side corresponds to this side and it's in the ratio 2 is to 1. Okay, how about in this third triangle? So this is our median. Midpoint, midpoint, this is our mid segment. We have these two triangles and these are similar figures. So this ratio 2 is to 1. This ratio is also 2 is to 1, including this median. So this side corresponds to this side. So this is in the ratio 2 is to 1. Okay, let's give an example by answering this concept check question. In a right triangle ABC with angle C equals to 90 degrees, so angle C is 90 degrees or right angle. Let G be the centroid, or this point is the centroid. If segment AB is 12 centimeters, we will find the length of segment DG. Segment DG is this segment. So how are we going to find the length of segment DG? So it's already indicated that angle C is 90 degrees. So it means this segment AB is the hypotenuse of this right triangle. Okay, it's also given that point G is centroid. So if this is centroid, then it means from this vertex to this point is the median of this triangle. Vertex to this midpoint. If this is the midpoint, then from here to here, B to D are equal in length. And since this is the midpoint of this hypotenuse, then it means this is also the circumcenter of our circumcircle. If we're going to draw our circle, then it would look like this. And this is our circumcenter. So if this is the circumcenter from here to here, from this point to this point, including this point up to this point, these are our radius and equal in length. A to B is 12 centimeters. It means A to D is 6 centimeters. B to D is 6 centimeters. And C to D is also 6 centimeters. We are looking for this segment DG. And since this is our median, then the concept would be it's in the ratio 2:1. And that is from the vertex of the triangle. So this ratio is 2:1. CD or segment CD is 6 centimeters. So it means C to G is 4 centimeters. And this segment DG is 2 centimeters. So for segment DG, this is equal to 2 centimeters.